Hi everyone, myself Varsha. In this session, I will be discussing about the register allocation. So we know we have many different registers from R0 to R15 and some specialized registers, that is SPSR and CPSR. We will now look at how the registers are allocated with some values. Register allocation is a fundamental concept in microcontroller programming. It involves efficiently assigning variables to the limited set of registers available on a microcontroller's processor. This optimization process ensures fast and responsive program execution. Importance of register allocation in microcontrollers. Efficient register allocation is crucial in microcontrollers due to their limited number of registers. Proper management of these precious resources can significantly impact performance, code size, and power consumption. Effective register allocation enables faster access to frequently used data, reduces memory accesses, and minimizes unnecessary spills and reloads, ultimately enhancing the overall efficiency of the microcontroller. Let's see what are the different types of registers we find in microcontrollers: processor registers, memory registers, and data registers. So there are three types. The first type, processor registers. Microcontrollers have a set of specialized registers that the CPU uses to store data, addresses, and control information during program execution. The second type is the memory registers. These registers provide a high-speed interface to the microcontroller's memory, enabling efficient data access and storage. Data registers hold the operands and results of arithmetic and logical operations performed by the microcontroller's ALU. Register file organizations. Microcontrollers typically have a register file, which is a collection of general purpose registers used for storing and manipulating data. The register file is a key component of the microcontroller's architecture as it provides fast access to frequently used values. The organization and size of the register file can vary across different microcontroller designs depending on factors like the target application, power constraints, and die area. Coming to different strategies for register allocation. Register file organization. The organization of the register file, including the number and types of registers, is a crucial factor in effective register allocation strategies. Static register allocation. Static allocation assigns registers at compile time based on a fixed set of rules, providing predictable performance but limiting flexibility. Dynamic register allocation. It makes register assignment decisions at runtime, allowing for more efficient utilization but introducing additional complexity and unpredictability. So we saw different strategies. So there were three strategies. In that, the second type, that was static register allocation. Under that, compile time analysis. Static register allocation performs a comprehensive analysis at a compile time to determine the optimal assignment of variables to the registers. Predictable performance. By resolving register assignments ahead of time, static allocation enables predictable program execution and minimizes runtime overhead. Limited flexibility. Static allocation lacks the dynamic adaptability to handle complex, unpredictable program behavior at runtime. The next one is dynamic register allocation. This strategy is demand driven as it allocates the registers required. It is flexible since it adapts to the program flow, and it is efficient because it minimizes the register spilling. Dynamic register allocation is more advanced technique used in modern microcontrollers. It dynamically assigns registers to variables as the program executes based on the real-time usage. This allows for more efficient utilization of the available registers, reducing the need for costly memory accesses. when variables need to be swapped in and out. Next one is spilling and rematerialization. Spilling occurs when a register runs out of available storage locations. In this case, the processor must temporarily store the register's value in memory, freeing up the register for the other uses. Rematerialization is a process of recomputing a value instead of reloading it from the memory. This can be more efficient than spilling as it avoids the cost of storing and retrieving the value from the memory. Comparing register allocation in different C compilers. So usually in laboratories we use Kiel compiler. So we'll see how the register allocation works in different compilers. GCC. The GNU compiler uses a combination of graph coloring and heuristic based approaches for register allocation. The Clang compiler employs advanced register allocation techniques, including iterative register coalescing and profile guided optimization. IAR compiler, commonly used for embedded systems, has a highly optimized register allocation strategy tailored for specific microcontroller architecture. The Kiel compiler, designed for ARM-based microcontrollers, leverages a combination of heuristic-based and graph coloring techniques for register allocation. To conclude, register allocation is a crucial aspect of microcontroller design, enabling efficient utilization of limited resources. As technology advances, future developments in register allocation strategies will likely focus on enhancing performance, reducing power consumption, and adapting to the evolving needs of embedded systems. Thank you.